In this video, we're going to take a look at the chain rule, which is really the way you should be looking at all derivatives. If you don't know what the chain rule is, it's simply taking the derivative of a composite function. Now, a composite function is when there is an inner function inside of some outer function. So in this case, g of x is our inner function, f is our outer function. Once we identify these, we're simply going to take the derivative of the outer function and multiply that by the derivative of the inner function. And there's different notations that you might see. So if u is some function of x and we're finding the derivative of f of u, it's simply f prime of u, which again is the derivative of that outer function, and u, which we don't know what it is our inner function, and we just multiply it by the derivative of that inner function. So the format I'd like you to see is that there is some inner function, and if we can identify that, that's simply what we're going to multiply by at the end. And in the beginning, we're just going to take the derivative of that outer function. Let's take a look at some examples to see. So if we're looking to take the derivative, d dx, f of x squared, what you should notice is that x squared is that inner function, f is the outer function because it's on the outside. So this will simply be f prime of whatever x squared is, and then you multiply by the derivative of x squared, which is simply 2x. It's like a little kick at the end. So another notation you may see is using Leibniz notation. So basically, if you're going to take the derivative with respect to x of y, and y is some function of u, and u is some function of x, so you can see the chain rule in action here. We have y to u, and then we have u to x. That's the idea of the chain rule. It's simply going to be the derivative of y with respect to u times the derivative of u with respect to x. Let's take a look at an example with that notation. So if y is equal to cosine of u and u is equal to x squared plus 1, we know that the derivative of y with respect to u is simply negative sine of u. And for u, the derivative of u with respect to x means we'll just have 2x. Putting that together, we'll have negative sine of u, but remember, u can be substituted back in terms of x as x squared plus 1 times 2x. And that would be dy dx. Now that could have been presented another way. Since u is x squared plus 1, we could have just taken that and substituted in for u. And then you would see it this way. So we'd be able to identify our inner function and just take the derivative of that outer function cosine, which is negative sine of that inner function, which we can write x squared plus 1. And then we're just going to multiply it by that derivative, which is again simply 2x. And we can write that as dy dx, and we can put that in the front, of course, and neaten this up and have negative 2x times sine of x squared plus 1. So from here on in, we should be looking for an inner function whenever possible. So here's another example where we can see that in this case, f of x is our inner function, so we'll identify that. And our outer function, well, if f of x is replaced with u, it's simply u squared. So when we take those derivatives, dy du is simply 2u, and we're going to multiply that by du dx. And du dx for u to equal f of x is simply f prime of x. Now we could put this back and say that we have 2 times f of x times f prime of x. So there are different ways to present our final answer. It all depends what our goals are and what the problems are asking. So here on in, I think there's a better way to look at all of your known derivatives. So if you're going to d dx, x squared, I mean, you know that's 2x. So let's go ahead and get rid of the x and go back and write that as u. So the derivative of u squared is 2u, but u is a function of x, so we're going to multiply by du dx. Now this is a big deal, because the thing I would like you to notice is that you're taking the derivative with respect to x, and u is a different letter. This is going to be very helpful in implicit differentiation. That's really what we're doing here. The letters don't match, so we're going to multiply by that little kick at the end, that inner function derivative. So with taking the derivative of any power rule function, if you have u to the n, that's simply n times u to the n minus 1. But since u is some function of x, we'll multiply that by du dx. So I'd like you to do this for all of your known derivatives. So instead of sine of x, we're going to write sine of u. That derivative is simply cosine of u, where we multiply by du dx. Derivative of cosine of u, we should know is negative sine of u, again, times du dx. Tangent of u, secant squared of u, again, times du dx. And if you haven't learned them already, when you learn e to the x, ln of x, inverse tan of x, all your derivatives, you can really write them in terms of u, and you're going to multiply by that little kick, du dx at the end. So let's go through our more traditional examples here. If we see y equals sine of x squared plus cosine of x, we can see that inner function. It's pretty obvious. Now, if we want to, we can go ahead and rewrite this. Some students prefer this. Y equals sine of u equals x squared plus cosine of x, and then they just write the derivatives underneath. dy du is equal to cosine of u, du dx is equal to 2x minus sine of x, and then we just put them together. So dy dx will equal cosine of u, but remember u is really x squared plus cosine of x. If the question is asked in terms of x, we answer in terms of x, but then we multiply by du dx, which is 2x minus sine of x. Now again, this could have been real simple. We could just go ahead and take the derivative of sine, which is the cosine of that function, and then we multiply by the derivative of that inner function. Number 3, y equals sine of x cubed tan of x. So again, pretty obvious that our inner function is x cubed tan of x. So in this case, we can say that we're going to have the derivative of sine is just going to be cosine of that function, which I'm going to leave blank for now. But then our u is x cubed tan of x. Notice we have a product here. So we're going to have to use the product rule to find this derivative. So hopefully you know that. If not, you can go back and take a look at those videos. But it's simply the derivative of the first times the second plus the derivative of the second times the first. I like to put the underlines here because so often when we're doing these problems, we get lost and forget to put things down. So the derivative of x cubed is 3x squared times the tangent of x. The derivative of tangent of x, we know, is secant squared of x times our first function. So if we neaten this up, we can say that dy dx is equal to the cosine of u, which was x cubed tan of x. Notice that does not change. Then we multiply by the derivative of that inner function, which we can write as 3x squared tangent of x plus, put the x cubed up front, secant squared of x. And that's it. Number 4, we see a cube root with a constant in front, so that shouldn't be an issue. Another way we can rewrite this as y equals 2. Remember that the cube root means that quantity to the 1/3 power. So when you're looking at this now, hopefully you can see that what you have is your inner function right here. So it's almost as though you can ignore that and just go ahead and take the derivative of 2u to the 1/3. So for this problem, let's go ahead and write that down. Y equals 2u to the 1/3 and u equals 4x squared minus 7x. Again, it's up to you if you want to do two separate functions or if you feel comfortable enough just to go ahead and know to multiply by the derivative of the inner. So in this case, I will write down dy du, and that's going to be equal to 2/3 u. 1 less is negative 2/3. And then we have du dx is going to be equal to 8x minus 7. Now we simply put them back together. dy dx will equal 2/3 times our inner function is the u, so 4x squared minus 7x, that will be to the negative 2/3 times 8x minus 7. Now again, we can clean this up and we can write this as a single fraction, so why don't I just go ahead and do that and squeeze that in here for you. So you would have 2 and 8x minus 7 would be in the numerator, and our denominator would have the 3, and then the 4x squared minus 7x to the 2/3, which again, different ways we can write that. For now, I will leave the exponential form. So again, another way this can be rewritten. Number 5. Number 5 is a little trickier than it may appear. It seems pretty obvious that 3x minus 5 is the inner function, but we have a squared here. So what you may want to do is rewrite this function so we have a better understanding of what's going on. So this is the idea that we have the sine of 3x minus 5, but there's another outer function here of being squared. So what we really have here is a triple chain rule. So you'd see the idea that you have something squared, and then we're going to take the derivative of that something, and that something is going to be taking the derivative of the sine of 3x minus 5, and then we're going to have to take the derivative of that 3x minus 5. So let's see if we can take a look at that. So the derivative of something squared we know is going to be 2 times that something, which I'll leave blank for now, to the first power. Times, now let's take a look at this right here. This we've seen, the derivative of sine is the cosine, and again we can leave the 3x minus 5 there, and then our derivative there is just 3. Putting this all back together, we would have 2 times the quantity sine 3x minus 5. Again, I'm going to write to the first power times the cosine of 3x minus 5, and that's times 3. Now, some of you may recognize there's a trig identity here. In case you don't know, I'm going to write it up here for you. We know that if you see 2 sine of A cosine of A, that is the same thing as saying the sine of 2A. Or as I like to say, I'd rather divide by 2, and when I see sine of something times cosine of that same thing, I replace it with 1/2. So in this case, notice that you have sine of 3x minus 5 and cosine of 3x minus 5. So again, with that 2 right there, we would have 2 times 1/2 of, and then we can just replace this with the sine of 2 times that 3x minus 5. And out here we'd have times 3. So you end up with 3 times the sine of, and then we can distribute that if we really want to, and say sine of 6x minus 10. So you may see your answer written differently. Sometimes trig identities will come back to you. Problem number 6. So in this one, a lot of people will moan when they see it because you're going to recognize that inner function is a quotient. So immediately we have to remember the quotient rule. So we're looking at y equals u to the third, and u is 2x minus 1 over x plus 1. So dy du is pretty easy. We know that's simply 3u squared. Now du dx requires the quotient rule. So let's go ahead and do that over here. Du dx. Now, quotient rule states we multiply by the derivative of the top, so that'll be 2, times the bottom function, minus the derivative of the bottom function, which is simply 1, times the top, 2x minus 1, and that's over the bottom squared. And this will clean up, and if we clean this up, you'll see that we're going to have 2x plus 2 minus 2x plus 1 when we distribute that negative. So those 2 x's will make 0. We'll be left with 2 plus 1. So this will be equal to 3 over the quantity x plus 1 squared. So now when we put everything back together again and have dy dx, we'll see that we have 3 times u, which is 2x minus 1 over x plus 1 squared, times 3 over x plus 1 squared. Now again, this sometimes will be written a little bit differently. Things you should notice, we have the 3 times 3, so we're going to have that 9. We can go ahead and write that down, and that'll be times the 2x minus 1 squared. And notice we have x plus 1 in the denominator here and here, so this is x plus 1 squared times x plus 1 squared. So this will be over x plus 1 to the 4th. All right, so that's something to look out for in terms of rewriting it. This does go together. number 7. Number 7, what I need you to see is really the structure we have here is the product rule, which has the chain rule inside. So here is our first function, here is our second function. Let's see how comfortable we are with this now. So let me just go ahead and set this up. We're going to have the first times the second, and then plus, I should say, the derivative of the second times the first. So the derivative of the first, we're going to have 3 times our inner function x minus 10 squared. And the derivative of the inner, notice in this case, the derivative of x minus 10 is simply 1. I'm just going to go ahead and put that as a placeholder so I don't forget. Our second function is simply 2x plus 1 squared. The derivative of our second function is 2 times 2x plus 1 to the first, and the derivative of our inner function here, 2x plus 1, is 2, so times 2. And again, times our first function. Again, this is the reason I like to put the underlines. A lot of times we get caught up and get lost and we just leave those things out. So now we do have that written down, which is nice. So cleaning this up a little bit, we're going to have 3 times x minus 10 squared times 2x plus 1 squared plus, we can write that as 4 times 2x plus 1 times x minus 10 cubed. Now this can be simplified, and it probably would be. So things I want you to notice is we have an x minus 10 squared, and we have an x minus 10 cubed. So that can be factored out. We can factor out the squared, so that term will be gone, and that will be reduced to a first power. So let's write that down, x minus 10 squared. Also, we have 2x plus 1 squared, and here we have 2x plus 1. So we can factor out a single 2x plus 1, reducing that by 1, and we're left with 2x plus 1 factored out. That leaves us with our inner value of 3, and we're left with 2x plus 1 plus 4, and here we were left with x minus 10. Simplifying this a little bit more, we get x minus 10 squared, 2x plus 1. Now we got to do a little bit of algebra here, so let's do that underneath. So save a little space. We'd have 6x plus 3 plus 4x minus 40. So that will come down to 6x and 4x, leaving us with 10x, 3 minus 40, which is minus 37. So our final answer is here in factored form. All right, our final problem has us using the classic table. So in this case, we're given some function h, which is defined as f of g of x. That's simply going to be using the definition of the chain rule. So we're going to find that value at 2. So the first thing I want to do is always write this down. So h prime of x is going to equal f prime of g of x times g prime of x. Again, that's simply stating the chain rule. And we are looking for h prime of 2. So that means we need f prime of g of 2 times g prime of 2. So we'll always start with that inner value, g of 2. Going to our table, here's 2, g of 2 we see is 3. So now we know we need f prime of 3 times g prime of 2. F prime of 3, so now here we're going to the 3 row. F prime we have 4/5, so we can write 4/5. And g prime of 2, we're back to the 2 row, and g prime is -4. So we're going to multiply by -4, which is simply -16 over 5. So again, that is the chain rule in action. Always look for that inner function, find that inner u, and then multiply the derivative of the outer times the derivative of the inner. Hope that helps.